Example 2, it says find an equation of the tangent line of the circle x squared plus y squared equals 25 with 0.34. First off, let's go back to geotrig real quick. It tells us this is a circle. How do we know this is a circle based on its structure? Anybody remember?
X squared plus y squared.
Yeah. X and y are both squared. They're both positive on the same side with the same coefficient. If it was 4x squared plus y squared, now it's an ellipse. If it's x squared minus y squared, now it's a hyperbola. If it's x squared plus y, now it's a parabola, right? So we have these different conic sections we dealt with last year. The radius, of course, would be the square root of 25, which is 5, right? 3 squared plus 4 squared is 25, right? So the 3, 4 is a point on there. We can see, obviously, 9 plus 16 is 25. Anyway, as always, remember everything you've ever learned in your entire life. That's always helpful in a math class. Notice that's the exact same problem example 1 was. Right? X squared plus y squared equals 25. So the first step of this problem, if I'm trying to find the equation of tangent lines, I want to find the derivative of the function. And we've already established the derivative of the function dy over dx is equal to negative y over, oh sorry, negative x over y, wasn't it? Yep. I hope I put the right derivative there. Negative x over y. There we go. In the event that you don't have the exact same problem you just did, of course, you differentiate that implicitly to get the derivative. Now the difference again between this problem and what we've done in the past with tangent lines with derivatives is we had f prime of x equals something about x, we had to substitute x in. Now we have a derivative dy dx that equals an expression involving x and y, so we need to use both of these numbers into this expression to establish what the slope is. It's still a derivative, so it's still the slope formula. Slope is negative x over y, so negative 3 over 4 will be the slope of the tangent line to this circle. Once I know the slope of the tangent line, now I've got an algebra 1 problem again. I've got a slope of negative 3/4, and it passes the point 3, 4, and I'm trying to find the y-intercept. I go y equals mx plus b, which gets me 4 equals negative 9/4 plus b. The 9/4 over. 16/4 plus 9/4 is 25/4. Slope of negative 3/4, y-intercept of 25/4, so we get y equals negative 3/4 x plus 25/4 would be the equation of the tangent line. Okay. And just for the sake of verifying this, let's draw the circle on our calculator. And before I get the calculator out to do that, our calculator likes explicit functions. Oh. Y equals, right? Everybody recognize that with our calculators? Whenever we type in an equation, we always type in y equals. Alright, so let's take a look at our problem. X squared plus y squared equals 25. That's going to be y squared is equal to 25 minus x squared, right? If I move the x squared over, it looks like that. And again, this is a basic implicit function. It's very easy to solve for y. There's only one y term in it. When there's more than one y in it, and especially when trig functions start showing up, a little bit uglier and it's harder to deal with. But y squared equals 25 minus x squared, which means y is equal to plus or minus the square root of 25 minus x squared. That plus or minus, the plus makes the top half, the minus makes the bottom half of the circle. Okay, that's why one function, x squared plus y squared equals 25, has to be represented by two functions when you change it to explicit form. And again, imagine if we're doing an explicit differentiation now, we have to differentiate a radical with the chain rule. We'd get the same derivative. It would just be all about x instead of x and y. Okay, so again, the implicit derivative is very much nicer to look at. The explicit one would be to look at. But if I come over here to my calculator, clear out this stuff here. I'm going to type in y1 is the square root of 25 minus x squared. Again, that's the top half of my circle. Negative the square root of 25 minus x squared is the bottom half of my circle. And negative 3/4 x, I have negative 3x over 4 plus 25/4 is my tangent line. And if I set a window, I'm going to go from negative 6 to 6 in all directions. The reason I'm choosing negative 6 is because the radius is negative 5, right? Or sorry, the radius is 5, so I'm going, and 0, 0 is the center. So negative 6 to 6. There we go. graph. Oh, you put negative 6 up there too. There we go. Top half in blue. It looks like an ellipse because it's not, it's a rectangle, and I put the same dimensions horizontally and vertically. We can fix that in a minute. My tangent line coming along here somewhere, there it goes. And it looks really tangent, right? The reason it looks like an ellipse is because this is a rectangle, and that 6 and this, or this 12 spaces and that 12 spaces, this is scrunched, so it gets squished like that. It's distorted. If you ever want to get a true picture of what it looks like, if you go to zoom square, zoom 5, it keeps the y coordinates the same, it changes the x coordinates. And the reason it doesn't quite touch is because it didn't pick exactly 5 based on where it's going, but that you can see there it's obviously a circle. If you do a zoom square, it takes the distortion out because of the rectangularity of the thing. So, you know, if you ever want to see what the true picture of something is, if you get the y coordinates figured out, the zoom square just adjusts the x coordinates appropriately to fit that on nicely.